Hello and welcome back. For this video we'll discuss problem solving using systems. Sometimes you can solve a problem involving two unknown quantities, talking about two here, most easily by using a system of equations. Since a system of equations generally has two unknown quantities in it, it works perfectly. The most difficult part of this process is defining the two variables, so we have to define our variables. Of course we have to do it accurately, and then in turn writing the equation from the words itself. Example 1. To use a certain computer database, the charge is $30 per hour during the day and $10.50 per hour at night. If a research company paid $411 for 28 hours of use, find, here's the information to look for, find the number of hours charged at the daytime rate and at the nighttime rate. Since that's what we're looking for, the number of hours charged at daytime and at nighttime, that's what we're going to let our variables represent. So we're going to say let D equal number of hours daytime and let N equal number of hours nighttime. Okay, so we've got our two variables defined. Now we got to write an equation. Well, we know that we have a total of 28 hours of use. And D and N are actually representing the number of hours of use. So our first equation is very simple. N plus D is equal to 28 hours. We also know what the total cost was to use it for 28 hours. That was $411. So we have an equation that's going to equal $411. Well, $411 is going to come from dollars plus other dollars. So how do we calculate the other dollars? We got dollars for daytime and we got dollars for nighttime. Well, the daytime hour use is $30 per hour. So $30 times the number of hours, which is D, is the daytime cost. And to that we're going to add the cost for nighttime, which was $10.50. I'm only going to put a 0.5, $10.50 in. And that total is $411. The next decision we need to make is which method are we going to use to solve? Are we going to use linear combination or substitution? Well, if you look at this first equation, both the coefficients of N and D are 1. When you have a coefficient of 1, typically substitution works best or works quickest. So what I'm going to do is isolate D in this first equation. So I'm going to rewrite that as D equals 28 hours minus N. So all I got to do then is take this value of D and substitute it right there in that equation, and then I can solve for N. When I substitute that value in for D, I get 30 times 28 minus N plus 10.5 N, still equal to 411. Then we're going to distribute this 30, and that will give us 840 minus 30N plus 1050N equals 411. Now I'm going to do two things at once. I'm going to combine these like terms, and I'm going to move my 840 to the other side using subtraction. So I'm going to do that one first. So 411 minus the 840 that's coming over will give us negative 429. And then when I combine my like terms here, I'll end up with a negative 19.5 N. And since we're using large numbers and numbers that involve decimals, it'd be best to use a calculator here. So we're going to divide both sides by negative 19.5, and N ends up equaling 22. Now remember, N is the number of hours of nighttime use. So we use 22 hours at night. So how many hours did we have in the daytime? Well, let's take our 22 here and substitute it back into this problem. 22 plus D equals 28. And then we can see that D is equal to 6 hours. So we got 6 hours of use in the daytime and 22 hours of use at the nighttime. Now, to be absolutely certain that this works, we should take both the 22 and the 6 and substitute both of them in here in the second equation and make sure it also gives me 411. Example 2. To measure the speed of a jet stream, a weather service plane flew 1,800 kilometers with the jet stream. Going with it means they have a tailwind, and then back again. When they come back against it, they have a headwind. Tailwind will increase your speed, while a headwind will decrease your speed. So they have the eastbound flight that took 2 hours, and the westbound flight took 3 hours 20 minutes. So it took longer going west than it did east. So we can tell which direction the wind is actually going. The question they want to know is find the speed of the jet stream and the airspeed of the plane. So we got two different speeds here. So these are the variables. So let A equal plane speed and let W equal wind speed. Now what they're giving us is speed, they're giving us a time, and they're giving us a distance. So this is really nothing more than a rate times time equals distance calculation. So I've got two separate equations. I got the eastbound equation and I've got the westbound equation because the times are different. The eastbound is pretty easy. It took 2 hours going eastbound, and eastbound was the shorter of the two. So if it was shorter hours, that means you were going with the jet stream. So your actual speed is the plane speed plus the wind speed. So 2 hours times that total speed is going to equal a total distance of 1,800 kilometers. When you're going westbound, you're going headwind or going against the wind, it's going to slow you down. So we're going to have airspeed, or the speed of the plane, minus the wind speed, and that's still going to be 1,800 kilometers. The only difference is they gave us that measurement in hours and minutes. Well, we have to convert it all to one unit. Well, since the top one up here is in hours, we're going to take 3 hours and 20 minutes and convert that to hours. So 3 hours and 20 minutes is really 3 1/3 hours, which I'm going to write as 10/3. We don't like to work with mixed numbers, so we have 10/3 hours times A minus W. Now the first thing I'm going to do is go ahead and eliminate the 2 and the 10/3. So I'm going to divide both sides by 2 on the top one, so I will have A plus W equals, when I divide this one by 2, I end up with 900. So now I've cleared out my parentheses. On this bottom one, I'm going to multiply by the reciprocal, which is 3/10, times this one by 3/10 also. And we will end up with A minus W equal to 540. Now, which technique should we use here? Combination or linear substitution? Well, since these variables are already lined up and they all have coefficients of 1, linear combination would be the best way to solve this. So all I'm going to do is draw a line here, put parentheses around the second one, and notice how the W's have a positive and a negative. So the easiest way to get rid of them is to add those together. A plus A will give us 2A. W plus negative W is 0, so that drops out of the problem. And of course I still got to do 900 plus 540, and that's going to give us 1,440. So to solve for A, we're going to divide by 2 on both sides. So A equals 1,440 divided by 2, which is 720. Now A is the plane speed, and that is in, this was in kilometers here, so this is in kilometers per hour. Go back up to, let's say, the first equation and put 720 in place of A, and then solve for W. After substituting, we'll have 2 times 720 plus W is equal to 1,800. Distribute, and we get 1,440 plus 2W equals 1,800. Subtract 1,440 on both sides, and we end up with 2W equal to 360. Divide both sides by 2, and we end up with W equal to 180 kilometers per hour.